Today we're going to be looking at the rational functions in simple form again. So for day 2, we are going to be including a domain and range into our notes. So let's go ahead and let's review some transformations and vertical and horizontal asymptotes from the other day. So if we take a look at warm-up question number 1, we have y equals 1 over x minus 5 plus 3. So just as a reminder, whatever is happening in your denominator, this is going to be your left and right movement. And remember, left and right movement does go opposite the sign, so an x minus 5 is going to go to the right 5. A plus 3, we're adding to the function, is going to move your graph up 3. The up and down movement occurs outside of the fraction. And remember, this is where we get our vertical and horizontal asymptotes from. So the vertical asymptote is coming from your left and right movement, and because we moved our graph right 5, our vertical asymptote is going to be x equals a positive 5. And because the graph moved up 3 units, this is going to push your horizontal asymptote up to y equals a positive 3. So taking a look at number 2, we have y equals negative 2 divided by x plus 1 minus 6. So as you recall, anything that's happening in your numerator, this is your stretch, compress, and reflect. And we see that there's 2 things going on here. The first one is that negative sign. So that is a reflect over the x-axis. And the 2 is greater than 1, and so that's a vertical stretch of 2. X plus 1 in your denominator, again, this is the left and right movement, so it does go to the left 1, and the minus 6 will move your graph down 6. So again, the vertical asymptote is coming from the left and right movement, so x would equal a negative 1 because it goes to the left 1, and the horizontal asymptote is going to move down 6 to a y equals negative 6. Okay, so let's go ahead and let's kind of put all of this together, but also include our domain and range. So taking a look at your parent function again, we can see that we have 2 branches, one in the first quadrant and one in the third quadrant. So when we are talking about domain, we're talking about the x values from left to right. So this branch that's in the third quadrant, it does continue to negative infinity for the x's. And if we pop over to the first quadrant here, this branch is going to go to positive infinity for your x's there. But as you recall, there is this vertical asymptote kind of getting in the way that we can't include this value of x. We cannot call this all real numbers because we're not including this x value right here where x is equal to 0. So our notation for that would look something like this. For a set builder notation, we would say x such that x is not equal to 0. Well, the same thing occurs with the range. And if you remember, range is from least to greatest, from bottom to top. Well, this branch in the third quadrant, those y values are going to go to negative infinity. And in the first quadrant, the y values are going to go to positive infinity, but there's a horizontal asymptote kind of stopping those y's right here from crossing this line. So for our range, we can say the same thing. We can say it's all real numbers, except for this 0. So this notation, the set builder notation, is normally what we use to notate our domain and range for a rational function because it's easier, it's shorter to write than the interval notation. And again, the meaning of this, it's saying all real numbers except 0. So just to kind of show you what the interval notation would look like, we're not going to write it and you're not going to see it on your assignment. You're going to resort back to the set notation, but just to kind of show you, it does go from negative infinity to 0. And then we put a union there because it's stopping at 0. It's approaching 0, but not going to touch it. And then we're going to pick up at 0 and go to positive infinity. So as you can see, And it's the same thing for the range. As you can see, the set notation is a lot easier to read and write than the interval notation. So again, just recall that your vertical asymptote is going to go through the x-axis. So your vertical asymptote is what's going to control the domain. And the horizontal asymptote, remember, goes through the y-axis. So that will control the range. Okay, so let's go ahead and let's put all this together. Okay, so let's go ahead and let's take a look at this first example. Let's identify our transformations, vertical, horizontal asymptote, and our domain and range. So for example number 1, we do have a vertical stretch of 3. It also moves to the right 4. I'm going to go ahead and write this up here. Right 4 and up 2. So we've been working with vertical and horizontal asymptotes. So hopefully you're understanding right now that your vertical asymptote is at x equals a positive 4. And the horizontal asymptote is at a y equals positive 2. Now for the domain, we can say that we have all real numbers except for, remember, the x value, the vertical asymptote, controls our domain, so we can say x does not equal a positive 4. And the same thing for the range. We should have all real numbers except for the horizontal asymptote. And as you can see, we have a horizontal asymptote at 2, so our range is all real numbers except 2. So just to kind of sketch this out a little bit, we can put 1, 2, 3, 4. Our vertical asymptote moved to the right 4. Our horizontal asymptote moved up 2. And then our branches are in the first and third quadrant. And hopefully you're seeing that the vertical asymptote in the domain, these are going to be the same numbers. Horizontal asymptote in the range, these are always going to be the same numbers. So let's go ahead and let's take a look at example number 2. Here we have a -1 in our numerator, so that's going to give us the reflection. The x plus 3 is going to go left 3. And the -1 is down 1. Okay, so our vertical asymptote is at x equals -3. And the horizontal asymptote is y equals -1. Our domain, remember, it's all real numbers except for the vertical asymptote. So we can say that x does not equal a -3. And a range is all real numbers except the horizontal asymptote. So we're going to say y does not equal a -1. And then to put a quick sketch on this, we're going to move the vertical asymptote left 3 units. And the horizontal asymptote, we're going to move down 1 unit. But there is a reflection over the x-axis. So instead of your branches now being in the first and third quadrant, we're going to reflect them over the x-axis. So from the first quadrant, we reflect down into the fourth quadrant. And the branch that was in the third quadrant now comes up to quadrant number 2. Okay, so now given the graph, can we identify vertical, horizontal asymptotes, domain, and range? So taking a look at example number 3 right here, we can see that this graph really doesn't move left or right any. We can say that our vertical asymptote is still at x equals 0. However, it looks like my branches are starting to approach y equals 4. So what is that going to do to the domain and the range? So remember, your domain is all real numbers except for the vertical asymptote. So we can say x such that x does not equal 0. And the range is all real numbers except the horizontal asymptote. So y is not equal to a 4. Okay, so looking at example number 4 here, we can see that this graph has moved to the right, and it looks like the branches are starting to approach 4 right here. So we can say the vertical asymptote is at x equals a positive 4, but it didn't look like this graph has moved up or down any. Looks like our horizontal asymptote has remained at y equals 0. So in this case here, our domain is going to be all real numbers except for 4. And our range is all real numbers except for 0.